Now this is the last session for the day, so I hope to see you all here tomorrow morning as well. Yeah, so let's begin. The chair of session 5 is Ms. Jude Biggs. Ms. Biggs is our senior conference advisor, as well as a partner at Holland & Hart. Ms. Biggs focuses on advising national and global employers with employment-related issues. Before entering law school, Ms. Biggs was the vice president and director of marketing for the Westview Press for 6 years. Please join me in welcoming here to the podium, Ms. Jude Biggs.
I think that Lakshman saved the most fun one for last. I know that I'm very excited to hear about some of the innovative ideas that the people that you're going to hear from are coming up with. And what I like particularly is that we spent a lot of time today talking about some really smart ideas and smart innovations and programs that will help move forward this agenda of energy justice. And what we're going to be hearing about now are people who are also very smart, but taking a practical approach and finding those solutions that work. So I'm very, very happy to have just a tiny role in this. We have two people that we're going to start off with who are both in the cook stove area. They are with very separate companies. One is Jason Propus, who is up at CSU working on his PhD in mechanical engineering. And he also does quite a bit of work with the engine lab up there. He's the sort of fellow that you might go to if you were in EnviroFit. And Jessica Alderman is going to be our second speaker, and she comes from EnviroFit. He would help you figure out perhaps some sort of engineering solution to having a particular kind of chimney on a particular kind of stove that would achieve a certain heat and so forth. Have I even remotely gotten it? Okay, good. Okay. So he's a problem solver. Jessica is a problem solver of a different type. She's with EnviroFit, which I know most of you would associate with cook stoves. And because of her branding and communications background, she's really helping to move forward on that idea that we were talking about this morning on behavioral change, helping to get the message across to people so that they will adopt these. We'll start with those two first. They each will talk for about 10 minutes, and then we'll move on to illumination and motive power, and I'll do those introductions at that point. But first, Jason, you want to start off?
Thank you very much for the kind intro. And this is a great conference so far. Good job to everyone who's organized it. And I noticed as I look around the room, at least 5 people have built stoves in Peru on trips I've been on, so it's really exciting to see how active this group is. It's funny to see you back in sunny Boulder. So today I'm going to talk to you, I'm going to make a brief argument for why I think we need to design cook stoves with the same scientific and engineering rigor that we treat developed world products and solutions. And the reason for that is these are appliances that are going into people's homes, into families' homes. We hope they're going to be used daily. And if you do that incorrectly, the consequences can be dire. So we need to treat it with the seriousness and the respect it deserves. And in that argument, I hope to show you what our lab's approach is. I work at the Engines and Energy Conversion Laboratory at CSU. And I'm going to show you a little bit of how we develop cook stoves there. So I'm not going to spend too much time on this because Corinne did a really good job outlining the scale of the problem. But over 3 billion people are using biomass as their main energy source on traditional stoves, which could consist of 3 stones with a fire in the middle of it. And over 2 million deaths, and that number might jump to 4 million when they start establishing ties with cardiovascular disease. So 4 million deaths per year due to indoor air pollution. And there's also a large environmental degradation effect from cook stoves. Inputs into greenhouse gases, deforestation, etc. And this is a really complex problem. On its surface, a stove might look like a fire in a bucket, and how hard could it really be? And I remember thinking that when I first came to CSU. But man, was I wrong. This is the intersection of some really difficult physical sciences with the even more intractable social sciences. You have to manage to control a fire its chemical reactions, the emissions that come from it, the thermal efficiency. You have to do all of that while accounting for regional cooking practices. And by the way, do it in a $20 package that people can buy. So it's a very difficult problem, and you mess up a lot when you work on it. So our approach at the Engines Lab, this is a simplified kind of process flow of what we do, is very iterative. The yellow arrows are perhaps the most important, and that's that you identify needs and develop specifications, and you run with that, and you try to model and simulate stove design, but you have to be open to changing that design. Sometimes it's minor tweaks, other times it's a complete overhaul of everything you thought was a good idea. And a lot of that comes from the field. When you have field studies and you see, wow, those handles that I thought were really cool are burning people and they hate them. So you have to be ready for changing things and not being offended by those changes, because it's ultimately users that are using the stove, and you want to make sure they get used. So the first step is an in-depth needs assessment. You need to understand in the field, in the region you're interested in working in, what do the current solutions offer? And those current solutions could be, as I said, 3-stone fires, but they offer something. Maybe they're really fast, maybe they're just really intuitive to build a 3-stone fire, easy to run, whatever it is, people are using them on massive scale, so there's something that can be gleaned from that. And what do those solutions lack, and where can you build upon it? And ultimately, how do you motivate a change? How do you get somebody that's been using this cooking style for centuries to suddenly take a big technological leap? This might not seem like a big leap to us, but to suddenly have a bright, shiny new stove, like the one you see down there, is very different than 3 stones with a pot on top of it. So you go to the sandbox. You start playing around with what concepts you think could make a big impact in these communities. And you characterize the existing solutions in the laboratory if you can. So sometimes we're replicating stoves in our lab in Colorado, in Fort Collins. Deconstructing them, finding out which measurements matter, which ones are not quite right, and ultimately trying to understand the physics of the type of cooking system that you're creating. When I make the chimney longer, how does that affect the airflow that goes into the front of the stove, and how does that affect emissions? And these things take time and resources, but they're really important to do. And we also have computational models that allow us to run through a large set of possible solutions before we build the physical models and test them, because that is so timely and expensive. So you can simulate a bunch of solutions and vet for the best, most promising ones that you can test in the laboratory and in the field. And one of the really wonderful things we have in the lab is a state-of-the-art prototyping facility. So we can take an idea to a working unit within hours in some cases, and that's really important to us because we're not creating designs, sending them out, and waiting for a box to arrive. We're building these ourselves, and in that you also learn a lot about the manufacturing challenges associated with your stove, because you want to make sure that you can build it so that other people can also build it easily and intuitively. And you have the capability for rapid revisions. If you got something wrong, go back and rebuild it and attach that to the stove and try that. And laboratory testing, this is obviously one of the most important aspects of process development, but we follow standards and protocols. Corinne talked about this some. We completely agree that if you're not following standards and protocols, you can't trust the data that you generate. And so what I want to know is, if I test a stove, stove A, that if it's better than stove B, it's because that stove is in fact better, not because I tested it differently than I tested stove A. And the way you do that is by following rigid standards and protocols. And we're in the process working with the Global Alliance to create protocols that everybody can agree on and execute, no matter what the size of your lab is. And also extremely important, because try as I might, I am not a Latin American woman, and I'm terrible at making tortillas. We want to try usability testing as often as we can. So here Maria is making tortillas in our lab, and we're testing for the ideal temperature to create a tortilla. And she gave us a really narrow band of 300 to 320 Celsius, which I would have just been guessing at and would have got completely wrong. And I was able to use that for the prototypes that we sent to the field, and that went really well because of her input. So you don't want to be robbed of this. You always want to have users involved as early on as you can. And ultimately, this is a relay race. You can't have one team doing the whole thing, from needs assessment all the way to commercialization. So we're really grateful to have commercial partners. The most prominent has been EnviroFit, which you're going to hear from Jessica in a minute, to take a concept and a set of data and the knowledge you've acquired and turn it into a product that can be put on a massive scale, because we're simply not capable of doing I make 3 stoves at a time. That's not going to change Peru, but I'm excited to work with people that can. So that's about all I had to say for today. Thanks very much.
You want to put it on there or put it here? I'll put it there.
Sure. Put it right here.
Yeah. You want? You want the other set? You want the other set?
That'd be great, sure.
This is the show and tell session.
Can I change?
Oh, sorry.
Yeah, come to the front.
Okay, great.
See, just tell, see what you get.
Oh, this is wonderful.
Are you?
I am.
You can even put it on your head.
Does the camera catch this?
Now knocking on it this last
I need to.
Yeah?
Anything else I can do to entertain you guys? Wow. Maybe towards the end? All right, I'll work on it.
All the way on the left from the beginning.
Great, sorry. An older version of PowerPoint.
Just let me know if you want to add this or
Okay, sure. My name is Jessica Alderman, and I am the Director of Communications at EnviroFit. And I am here to talk to you about our marketing and developing and distribution process. So we've talked about this a little bit, so I'm not going to go into too much detail, but what is it like to cook on a traditional cook stove on the local level? I want to introduce you to Chukulisa, and she's from Calcutta, Kenya. And what is her daily life cooking over a traditional cook stove like? She walks about 14 kilometers every 2 days to collect firewood. She spends about 35% of her income on cooking fuel and uses up to about 10 kilograms of wood just to cook 3 meals over a fire every single day. She also spends most of her time in a smoke-filled room in the kitchen cooking for her family. She's not alone. As Corinne mentioned before, indoor air pollution, being in a smoke-filled room definitely has health risks over time. Causes 2 million deaths globally. That's something that Corinne talked about in detail. Also has environmental degradation, using the forest and the resources, and also contributing to global greenhouse gases. It also puts women at risk when they go and collect firewood, which is something Corinne also talked about in detail. Bringing it down to the actual problem, poor fuel combustion. So that's kind of what EnviroFit focuses on. It's actually the fuel combustion that's what causes indoor air pollution. 50% of the wood's energy is wasted cooking over a 3-stone fire. So you're losing a lot of potential energy in using a traditional cook stove. It also adds 600 million tons of greenhouse gases to the atmosphere every year. So this is what we're looking to change: environmental issues, health issues, economic issues. So how does EnviroFit address the problem? We are working to, oopsie, I feel like this is, no, sorry, I'm backwards on this, sorry. So this is where EnviroFit comes in. We were established in 2003 to develop clean energy solutions to improve the human condition on a global scale. We started in about 2008 to 2009 is when we started focusing primarily on cook stoves. And we are working towards a vision in which people living at the base of the economic pyramid can enjoy durable, affordable, and aspirational, well-engineered technology products that offer both payback incentives and improve health and the environment. It's kind of a big goal. But how do we do that? Addressing the problem of poor fuel combustion. So engineers working with the lab that Jason talked about earlier and our research team, we've been able to develop a clean cook stove, which you see here, model that burns about 80% cleaner, requires less fuel, reduce costs, reduce cooking time, and overall improve stove cooking efficiency. And so now that we understand the problem, how do we then take that to scale? How do we market it so that it actually influences people's behaviors and actually gets people to adopt the stove? So first of all, we have to have that focus on quality. We want to have a product that we can stand behind, that we can say that we're proud about and that people are going to use. So focusing on quality, focusing on making sure that that product is something that people will use. And that's when we focus on our research. and making sure that we have a product that is the best that it possibly can be. It's durable, it's going to last. We offer a 5-year warranty with all of our stoves, and we're able to, because we use carbon finance, track the life of those stoves and be able to connect with all the consumers who use our product. So finally, we have quality. We have also, working with different cultures requires different products. We're not taking a one-size-fits-all approach. We don't just have one stove. We have an entire line of stoves depending on the product, depending on the consumers that we work with and the needs that they have. And so here's an example of the product line that we offer now. We have a built-in model. A plancha model is coming in the near future for Latin America. The G33 was very popular in India. We also have the M500, which we're marketing across Africa now. And then we have also different pot skirt attachments, depending on what type of pots people use and how they cook their food. Oh, sorry, for some reason this got mixed around for some reason. So how are we able to customize our products? We have to connect with our consumers. And connecting with our consumers is something that we do through our quality partnerships, that we do through our partners. For example, the stove that you see here, actually I'm gonna grab this.
Yes, it should be.
So this is the G3300, can you hear me from here?
Yeah.
So we work with a partner in India. This model in general was very popular in India, but there was a part in northern India where our partners came back to us and said, hey, they love the stove, they love the design, but they use a specific type of rotla bread that would burn with this direct heat. Is there any way that you can adapt the stove? So we take the stove back to our lab, and we develop this attachment, which is now called the rotla attachment. And you can put over the stove that diffuses the heat, so it doesn't burn that specific type of bread that they cook in India. So we are able to culturally adapt our products depending on the type of people that we're working with. Let's see if I can go back. These are out of order, I'm sorry about that. So in order to connect with our consumers, we need to be able to develop quality partnerships. And what does it take to develop those quality partnerships? That also differs depending on what area of the world we're working in, what country we're working in. We work with NGOs, private companies, governments. We don't discriminate. We just try to find what's best for the market, what's most respected in the field. We also need to be able to provide our partners with a sales incentive so that they have a reason to sell our stove, they have motivation to sell our stove, and they have to be able to convey the product value to our consumers. So this here in the picture is an example of one of our distributors, and he's in Kenya. And he was able to, we worked with him, tried to figure out what his market needs were, tried to provide him with the material that he needed to market the product. And he went out, he would do stove demonstrations. He would cook a lunch for the people who are coming, go village to village, and he ended up selling 1,000 stoves in a day. So 1,000.
A day?
In one day, he was able to sell 1,000 stoves. So it's connecting with those right partners, being able to communicate the product value to them, and providing that sales incentives for them to sell the product. Oops, sorry, backwards. And so how are we able to provide that sales incentive? So we have a focus on trying to provide localized manufacturing. We recently opened up a factory in Kenya, so it makes distribution a lot easier, quicker, and it allows us to be a lot more cost effective in our distribution. And currently our stoves sell for just under $20. So it's still, it's actually cheaper than what it costs to manufacture as a result of our carbon credit financing. But localized manufacturing makes it more affordable and easier to distribute. Oops, sorry. So what does this mean over time? So quality partnerships, connecting with our customer, being able to customize our product. What does that mean in terms of impact? Well, in just 4 years since 2008, 2009, we've enabled 400,000 families to purchase stoves, impacting more than 2 million people in over 55 countries. So we've been able to have an impact on the environment, have an impact on health, and be able to and have an impact on the economy, creating jobs locally. On a local level, what does that mean? Coming back to Chukwulisa, now that she has a quality product that she can rely on, she's able to protect her family from the harms of indoor air pollution. Because she spends less time collecting firewood and cooking, she's able to spend more time with her family. And finally, with all the savings that she has from not spending money on fuel, she's able to save enough money to send her kids to school. So that's what we're doing on a local level. We're always looking for quality partners. We're actually going to be releasing an RFP this week for stove subsidies as we're rapidly expanding across Africa. So definitely keep an eye out for that. You can learn more about us from our website, or you can sign up for our newsletter. Come talk to me afterwards. We're always looking for new partnerships. So. That's it.
You want that cook stove back?
Lakshman wants the cook stove, so watch him when he leaves tonight. Thank you. Those are two examples of the great innovations that are helping to make the adoption of clean cook stoves a reality. And as you can see, it takes a lot of adapting and learning along the way, and sort of in an engineering way and from a business perspective. You learn as you go, you adapt, and then you move on from there. Our next speaker is going to be talking about illumination. Imagine how easy we have it, because we can do whatever we want to at night. We just turn the light on and we keep on studying or reading or whatever it is that we're doing. That's not true, of course, for many parts of the world. Steve Katsaros is the, I guess his title is Chief Inventor and CEO. I suspect followed by that is probably Chief Troublemaker of Casera, which means no kerosene. He and his team have come up with a number of different devices that provide solar-powered reading light or light bulbs and other very simple things that can make a real difference in the world of illumination. So I'll turn things over to Steve, and I think that you'll be very interested to hear what he has to say.
Thank you.
I'll just balance them up here. They're durable, so they don't break. And I need a second to just pull up my set of slides. Let's do something fun if I can here.
Steve, you only came back from China like 6 hours ago, right?
Yeah.
No, that's not a joke.
We're going to start, yeah, I was in China and I just got back. But we're going to start off with a public service announcement. Imagine if you were in China, somewhere in Africa or India or Asia, and you're trying to learn about ways to change your life. And you know, this is a campaign that we've funded to date, but we're looking for funding partners at solarcampaign.org. It's not a Nocero product. It's not involved. It's relatively involved with us in that we're funding an individual whose name is Firdaus Karas, and he's a behavioral change expert. So this is one. It's an animatic. There's 30 of them or 15 of them that are going to be produced once we have full funding. And if the internet.
Would you like to walk together? We can share my solar lamp.
I can see just fine.
Need some light?
There's a snake. Can you see it?
I can.
Solar lamps provide light for safety.
So that's just an example of something that works in a developing world context. They can be localized with the proper languages from all around the world. And Firdaus is an expert at this type of process and end result of creating mass adoption of new technology. So, having dispelled with the public service announcement, first off, who has energy left over from our morning session? Who was here for the very first? Okay. Good. So hopefully we have some of that energy because here at 5:30 we need it, and I promise to use less
You want to do a little
than my.
energy?
I forget that. What was the
What was the chant?
what was the
You
chant?
remember that?
Anyways,
Remember that?
so Nocaro is all about extreme affordability. We really try with all of our products and our business process to deliver products that are affordable. I believe, and I am the chief designer of these products, that the single most important impediment to mass adoption of these products is to drive the price down. And it's not about the technology as much as it is about the business process. So the presentation I'm going to give you today is how Nocaro is doing this and talking about assets from our perspective. Our mission is quite simple. We bring power to the powerless. But I think that I should change that. I think that we should talk more about the power that we use every day. Nobody walks into my house and tells me how long to take a shower. There aren't any public service announcements talking about how long I should take a shower or that I should adopt LED lights. How many people have CFL lights in their house right now? This is a real clued in group. This is great. I'm very impressed. Thank you. So our mission, as I just mentioned, was bringing power to the powerless. And the proof of this value is like this solar lamp, right? As you've heard several times today, that lighting is a big issue around the world. Okay, $40 is 40 liters of kerosene. There's a report by Evan Mills that talks about 40 liters on average being consumed. This is 77 billion liters a year of kerosene. All right. And the break even on our products at full retail, unsubsidized. Yes, we have UNFCCC approved bulbs for carbon credits, and we have programs registered in India. But the break even in Haiti is 90 days. Okay, and as you can see here in Mexico, you save 10 pesos per night. That's 80 cents per night by switching from candles to kerosene lamps. And then we just received a report back, an official report from Pakistan, where they're spending $15 a month on lighting needs. Mobile phone charging is an emerging need. Right now, you have 700 million people who live without electricity yet have mobile phones. I've seen it with my own eyes where, in the Rift Valley in Kenya, somebody, you're like, this person has nothing, and out comes a mobile phone. It happens everywhere. I mean, I think we've probably all seen this where you're just shocked. But they're walking untold distances to charge their mobile phones. Maybe it's on a market day, but at any rate, in about 3 to 4 weeks, you're able to afford having a mobile phone charger. This is a full watt charger. It has accessories for adapting to any I'm just doing a little time check, any mobile phone battery without cables, without fuss, without muss. It's reduced in complexity, which reduces the price. Proof of how we do this and proof that we're successful at what we do is that in 2 years, from launching in June of 2010, we've sold 400,000 lights to 120 countries. We've generated $3 million in revenue, and the investment to do this out of my funding source was $60,000. Okay, so the proof of this is something that we'll get into the assets, right? That it's important to have the appropriate sustainable energy technologies that you're bringing to market on commercial merit, not on subsidized merit. By appropriate, we mean low cost, high value, durable products. These things they're rough. They take a lot of impact. We have mobile phone, or excuse me, I misspoke, solar book lights that challenge the price standard set. We wholesale this at $4, just under $4. It gives students the chance to read at night. Our N200, which is not this model, but it retails, we wholesale that at $5.50. This is a new product that any of you who have lived in a developing world and have experienced blackouts will fall in love with. It's got a battery that gives backup to these LED lights when the grid is broken. Because of the 1.3 billion people, that doesn't count another billion that have such intermittent, unreliable energy that they're burning diesel and kerosene and diesel generators. In a town, I was in Lahore, Pakistan, and like this, you hear this huge roar of diesel generators, and it's because the grid has gone out and everything switches over to backup lighting. That's when I came up with the LED shed. It also has a mobile phone a port for solar charging if the grid has been down for a long time. Sustainability to me means something then to a lot of you in the room with the environmental background. There is a typo on this. $12 should be $6. Late last night on jet lag, I was editing this. But the proof of sustainability is giving everybody in the value chain, in the supply chain, profit, right? I need some profit to fund my company. The retailers need 50% margin in order to develop their markets. And so the most important part about this image is showing that, we acknowledge the realities of getting these products across the 120 countries. It's important that everybody that touches a product have profit. There's no sin in that. Having contributed income is far much more work than having earned income. Nocero is based on earned income as a for-profit entity. I find this to be quite interesting. At the last night, just getting ready for this, I was thinking, energy. What does energy mean in an asset context? And I started to think about, well, what's the impact that we've had? 400,000 lights. Let's say that 300,000 of them have made it into countries with energy poverty. Do a little time check here. And what that means is that these 300,000 lights that are burning 40 liters of kerosene a year, we've saved 12 million liters of kerosene in 1 year of operation of the products that we've already distributed. So, at 2.6 kilograms of carbon dioxide emissions per liter, you can see the math here, it's 32,000 metric tons. Technologies, I could tell you, whatever, I know how to design products. It doesn't matter, it's such a marginal, small component. What's more important is to design a company that can deliver these products at an appropriate price. Right? That takes a lot of energy. Our organization works hard and we demand that. But one of the ways that we do this, to give you a little insight into how Nocero runs, is we use the media to get our word out. We focus on this. If you pick up Martha Stewart's magazine this month called Whole Living, we're in there with this product. Right? And what that does is not necessarily get to the base of the pyramid where we believe in and operate on delivering products. That is obviously atop of the pyramid market, but it generates revenue that funds our real critical work of bringing these products to the people who need them most. The companies or the countries that we work in are quite wide. I think Haiti is our single largest buyer to date. We have a partnership with Eureka Forbes there. They have 10,000 door-to-door sales guys. They're called Eurochamps. But we also work in a lot of other countries. So our trajectory here with our accelerated program is that in the next 3 years we'll have delivered 3.3 million solar products. And I don't know. Think about asset. That's what I see. So, anyways, the only reason why I have this slide up here is for my contact details, and I urge you to take action about this, not for Nocero, but for our entire sector, by visiting solarcampaign.org, and on there is a link to Indiegogo, where you can make a contribution to these very important public service announcements that create the change that's needed to create an overwhelming demand in country that all solar companies are able to supply products to, because we're going to overwhelm the system by having so much in-country demand. If you need anything else from me, I know, but you can email me and I'll tell you, but solarcampaign.org. And that was what you saw, that animatic. That's just a draft, that's a prototype. But anyways, you can learn more at solarcampaign.org, which is a non-Nocero event. And if you're interested in Nocero, please visit our website. We sell samples off there. But thank you for having me today.
Dr. Arjun Makajani is going to be speaking to us as our final speaker this afternoon. He is the president of the Institute for Energy and Environmental Research in Tacoma Park, Maryland. He has a engineering background, PhD from Berkeley, and made me promise to keep his introduction very short. So there it is.
Let's see.
Navigate to the desktop, I
I think I can do that. All right. I am going to talk to you about what I think is the most neglected subject in energy in the world, which is draft power in agriculture. I first wrote about this in the 1970s in a book, Energy and Agriculture in the Third World. You can actually download it free from the Ford Foundation's website site still. As preparation for my going back to India and working in the villages, I think I did myself more good by doing that than anybody else, because I was a urban boy in the villages and I had a lot to learn, so I did that. But in 1990, a colleague of mine was at the Office of Technology Assessment. She said, Arjun, nothing much has changed since we worked in the 1970s together. And they had prepared a methane and animals report, and she said, well, what about the question of draft animals? I've tried off and on, not very hard recently, to get this at least on the energy map, to get these numbers counted. So I hope this will be a start.
We found you.
Yes, yes. And the graduate students who found my report should be congratulated. And Lakshman should be congratulated. All right, so I'm going to talk about both of these things, bullocks and tractors. I'm talking about mainly motive power in agriculture, plowing the field, threshing, irrigation. I'm not going to talk about the electrical component of it. So this is overall urban and rural South Asia. As you can see, even if you count all the urban energy use, in Bangladesh, out of a total of 9 or 10, only 2 is urban. Now these data are old, since my study was from 1990, so these numbers have undoubtedly changed. But if you go from the whole picture to the rural picture, it's dramatically different. All right, rural per person energy use in South Asia. Now, there's a big component of energy for draft animals that's not included in this, which is the non-working animals. The cows you need for reproduction, the young animals that are not working that you still have to feed, and so on. So you see in Nepal, out of a rural Nepal, modern energy, these are inputs, 0.2 gigajoules per person, and draft animals 5 to 10. But this 5 to 10 is nowhere to be found in the energy data, not present. In all cases, independent, now this is, we're talking about 1.4 billion people, out of which 60 or 70% live in villages. So we're talking about something that affects about 1 billion people, just in South Asia. And then of course there's probably another billion elsewhere in the developing world. So I wanted to compare the installed horsepower. So basically we're talking horsepower to the USA, where all this is done by tractors. You can see it's not as dramatically different as you would think. Now, first of all, I should tell you, these numbers are very soft. These data are, they should have pluses or minuses, but really, there are a lot of uncertainties in this data. Cultivated area, not. But in the draft animal power, there's a lot of uncertainty because the per animal power is not well measured. The number of draft animals is not well known. Different sources will give you different numbers. This was my best judgment The number gods do love me, so it's probably a good judgment. But still, these numbers should be refined. As you can see, there's not a huge difference between a farmer using very traditional technology, but in some parts of South Asia, I have personally observed, if you go to the Deccan, you need 3 pairs of bullocks to plow those fields. And usually, poor farmer will have none, but a really poor farmer, he will have to rent them. It'll be last in line because the farmers who own them are using them in their own fields. He will probably be able to rent just 1 pair. He will have no power for irrigation, and I'll show you the consequences of that and comparing if you had sufficient power, what the differences in energy inputs and outputs would be. All right, so what are the pluses of draft animals? Lots of people have them, so there are obviously some pluses. They reproduce themselves, so once you've made the capital investment, there's a running cost to it, of course. They provide cow dung as fuel, so in taking into account the fuel, the outputs and the net energy is not as simple. So you have meat, milk, leather, cow dung, and then you have draft power output. So they're multi-purpose machines, and you can love them too. People love cars, so you can love a tractor, presumably. I don't know. I've never loved a tractor, so. But they are flexible in that they can be used for lots of different things. They can be, one of the reasons I asked about transportation earlier is you can use bullocks for transportation. You don't need a separate machine. You can use tractors for transportation too, and in rural areas often done. So they're non-monetized to a large extent, and this is a big, and one of the big advantages is when you have a tractor and it says on the nameplate, it says 100 horsepower or whatever, that's the peak power. That's the maximum that you can get out of it. Most of the time it's not running it, or your car, not running at the rated horsepower. It's a fraction of that. Whereas we have a horse or a bullock, that's normal output is a horsepower. In a tough spot, it'll give you 5 or maybe even 10 if it's in good shape. So this is a big advantage. Minuses, very low efficiency, as I'll show you. For the whole system, the efficiency is actually very low because you've got lots and lots of energy inputs. You've got to feed them when they're not working. A tractor has the big advantage of being able to be turned off, whereas you can't turn off a draft animal. It's got to be alive. Large land requirements. This is it's the simple things that are kind of, I tell people I specialize in the obvious. So this is a important thing. You got to feed them 365 days, and they work a small fraction of that. So there is I don't know that I have well quantified the deficits, but I've observed that there are large deficits, and you can get an idea for the difference in installed horsepower between the US from quite a long time ago, 30 years ago, and South Asia, that there is a serious deficit. You can see the differences in the outputs also. And poor farmers who don't have draft animals have to borrow money. They cannot, so cattle require capital investment. You got to initially start with a very significant investment. And then you have to, of course, if you don't have sufficient land, you'll have to purchase the feed. And one of the biggest disadvantages is if you have a shortage, then it will affect your output. One of the problems with draft animals and slow harvesting is if you have bad weather during harvesting, you can suffer large crop losses. So here's some data or calculations for India. The modern inputs, 560 petajoules in rural India. Efficiency probably 15-20%. Energy output, so this is the energy services that we were talking about earlier, so about 100 petajoules. The system basis input, including for non-working animals in India, is much, much larger, 5, 6, 7 times larger, but the outputs are lower, and the efficiency is only 1 to 3%. So this is a very, very big problem because you're not really interested in the energy inputs. You know, we don't get our jollies by sticking our fingers into a plug. We're interested in refrigeration and air conditioning and so on. And in the same way, we're interested in the motive power that the draft animals or tractors provide. Grazing land requirements, as you can see, if you look at the data on grazing land, you will see that in India and Bangladesh, there are very serious deficits of land that is designated as grazing land. So what is happening, obviously, for these deficits, you have poor quality draft animals, they're not getting enough to eat, especially in certain seasons. And then land that is otherwise classified, forest lands and grasslands, is being used for pasture when it's not classified. So there's a data problem as well as an understanding problem is what is the actual land use requirements. So besides the energy, there are alternative uses for this land. You can't just take this land and put it to other uses because there's a question of rights. Some people have access to this land today. They may be traditional rights. They may not have pieces of paper. It may be common lands on which poor farmers are grazing their. So if you suddenly change the system, they may lose rights and they may lose income and they may have nothing to substitute it with. At the same time, they do have serious deficits. And I have to say these are very, the actual grazing land requirements, you know, depends on the numbers of draft animals, how big these draft animals are. These numbers are fairly soft. I mean, there are ranges for that reason. And you can see that the range is all factor of two uncertainty to the best that I could tell. So what's the effect of all of this? So if you have, now this is sort of my back of the envelope estimate for what might happen in the Deccan, which is the main part of the Indian Peninsula, not the coastal areas where they grow rice, but where there's a lot of dry land agriculture, where the draft power requirements are pretty serious and often not met. So on the right, you see a one-crop, unirrigated, traditional, low-power input, one crop per year. You have low-energy inputs, 11 to 19 gigajoules per hectare per year, and about 7 gigajoules of food output, and 16 of crop residues. Crop residues are very important energy output because you can use them for fuel. You can, the cattle might eat, some of it goes back to the animals. And so the total energy output is 23. You can say a ratio of 1.5 to 2 of energy outputs to inputs. If you observe the same system, the same land, with a different system, I'm not talking organic versus non-organic or petrochemicals versus biogas. I'm just talking efficient machines versus the traditional system. So you have much bigger total energy inputs. You're growing 2 crops a year, about 100 gigajoules per hectare per year, but you have 200, so the same land, so you're in a situation where you're land short. And you have a lot of people per unit of land. So obviously, we talked a lot about, you know, food production and where it is headed. A lot of land is devoted to traditional agriculture. Now, I'm not saying that we should all have, you know, fertilizer inputs, and there's a lot of other issues in regard to the quality of land, pesticides, how do you want to maintain the quality for a long time? What about water availability? But this is a schematic to highlight the importance of having an adequate supply of energy service outputs. So you have a total energy input of 100, but on the left side, it's hard to count the energy value of the fertilizer in terms of outputs, but you can if you do the crop differences. Your outputs are probably on the order, your inputs will provide you with energy services that probably are like 20, 30 gigajoules per hectare per year on the right, on the left side there. And on the right side, it will probably provide you with half a gigajoule per year. So the differences in energy outputs are almost like closer to 2 orders of magnitude, even though the differences in energy, unfortunately I didn't think to show them, even though the differences in energy inputs are just about a factor of 5 or 6, 7, 5, 6, 7, like that. And that's why these outputs are different by an order of magnitude. You have energy outputs that are 10 times greater with an energy input difference that is 5 times greater, but useful energy input that may be 30, 40, 50 times greater. All right, so what shall we do? So back of the envelope, if you say, well, we're not going to do as much as the United States, but it should be a third of that or somewhat roughly comparable per hectare if you really want to do multiple uses and irrigation and so on. Independent of the kind of motive power you have about 100 gigawatt deficit. This is a bigger deficit than the deficit of electrical energy as calculated in India. So India has had the distinction of having a 600 million person blackout recently. Some of you might have read about it. And that, I think the deficit of installed capacity in India that produced that as officially calculated is a few tens of gigawatts. This is a very rough estimate. So there are 2 things that you can do. 3 things you can do. You can increase the number of animals, which is a bad idea. Because if you increase the number of animals, you're increasing a very low efficiency system. You're not going to reach the poor because they can't afford these animals. That's why they don't have them in the first place. The capital investment is large. They can't afford the feed. That's why they get into debt renting animals. They often lose their land. But it might interest you to know, where did I get all these numbers? A lot of the efficiency tests for animals were done on a treadmill in Scotland. There are almost no field data on this subject that I could find. Now, there may be today, so I haven't looked for 20 years. Well, I haven't worked on this for 20 years. Lakshman's people found me and said, come and talk. So I said, it's going to be based on my 1990 research, and I'm going to come do it so we can maybe put this issue on the map. But I didn't hear anybody else mention it today, and we had lots of very, very current, well-informed people who are working on the global stage. So I'm reasonably confident that this issue is not yet on the map. Am I right?
Yeah.
So the marginal efficiency of an animal, you feed a starving child better, they're going to function better. I think, all the stuff they said, poor children, you damage their brain. I think if you feed them better and love them, even if they have not been well fed for the first 2 or 3 years, they will flourish. That's my bias, maybe. Anyway, the numbers on the animals for motive power output are clear. The marginal efficiency is quite comparable to modern machines. So one answer, obviously, is to feed the existing animals better and increase the power. I also think that small petroleum machines, now these machines can use biogas, they can use different kinds of fuel. So I'm not arguing fossil fuels versus something else. I'm just saying that that modern machines can actually help poor farmers who may not be able to afford draft animals or machines if we have the right financing models. And you heard a lot about financing, and that's a big part of the problem. I think that for agriculture, direct mechanical power of the old style with better windmills, better adapted, the kind of research that is being done for cook stoves should be done for wind turbines that will directly pump water into a tank that can be used for irrigation. because then you don't have to convert it to electricity, worry about storing the electricity. It's all very, very expensive. You saw some of the numbers today. I didn't even know that small wind systems were that expensive. They're pretty horrendously expensive. I would say unaffordable. At least unaffordable for these applications. All right, so we actually need information. We need field measurements. We need them regionally. If you need to tailor the cook stove for the people you're using them regionally for what they're doing, we need information on draft animals in the Deccan. It's going to be very different from the west coast of India. It is going to be different in Haryana, and it's going to be different in China and Indonesia and Vietnam. And we need this information. This research needs to be funded. First of all, the need needs to be recognized. The data for inputs to draft animals need to be compiled along with oil and electricity, and even wood is not uniformly in energy data, which it should be. And it should be, this draft power question should be joined to the broader issues of rural and national and global energy, electricity for lighting, irrigation, the other things you have heard about. I personally have long felt that local utility models may help join some of these questions, and it could be private models, it could be cooperative, it could be local government. Different things will probably work in different places, and you could solve some of the financing issues in that context if you have banks that will loan money to poor farmers so they can actually lease a tractor so they don't have to go to the money lender, borrow money and borrow cattle. It may help. These are all kind of schematic ideas. My main message is, for all the attention we're giving this issue, in some cases, the very biggest component of energy in developing country rural life, and in many cases, a very, very large component that affects a couple of billion people, is not being attended to at all, despite all of our attention to the energy issue and global warming issue. Thank you. You're not asleep yet. Congratulations.
I learned a long time ago that people think you're really smart if you can get people in a conference out on time. So we have 2 minutes. And I'd really like for you to think I'm smart. So why don't we have just a couple of questions, and then we'll thank our panelists for their contributions and get you out of here on time. But I know that there's probably more questions than we have time for, and I assume that people can stay afterwards and answer those questions, but I want everybody here to feel comfortable in leaving too. Okay, ma'am, I think you were first. Oh, okay.
Luca Pwanga from Regis University. My question is directed at Jessica. You talked about the fact that you do give the stoves out because they are subsidized, so you charge less than $20 per stove. Mm-hmm. So what happens once that subsidy expires? What plans are in place to replace those subsidies?
After the subsidy expires, in terms of...
Yeah, because then it means the cost of the stove will have to go up automatically, isn't it? Supposing you are being subsidized for, how much does it cost you to make that one?
It varies depending on...
Okay, let's assume it costs you 40. And, okay, 35.
Yeah, so
I'm willing to negotiate.
It's 35.
So 15, after the expiration of the subsidy, that means that stove will have to at least be $35 for you to just break even.
We actually use a carbon finance program to help subsidize our stoves. So it's a very complicated process that I'm still trying to understand here as I begin my job here. But we use carbon credits to be able to subsidize the stove. We have to keep track. As a result, we have to keep track of all the stoves and where they go. And we take the hit in the beginning to subsidize those stoves, and then we recapture that funding later. Yeah. if that makes sense, through the carbon credit model.
Could I say something about what Jessica just said? I think one of the things that struck me in her presentation, what she just said, is that because of the way they're subsidizing this, they actually have to track the stoves. I think that has a lot of benefits that have nothing to do with the subsidy. Because you know how well it's being used, you know whether the customers like it, you have a contact with the customer that's very important. I presume that you maintain more contact than just for keeping track of it.
Okay.
Yes, my question is for Jessica. In the markets where you operate, do you have a lot of competition from makers of other charcoal or wood-burning stoves or solar? Are you looking into moving into solar stoves?
We are not specifically looking into moving into solar stove because we haven't seen a demand for it. We basically go with what our consumers want. If they traditionally cook over wood, we're going to build a stove in which meets their current cooking requirements and what makes the most sense to them culturally. We do have a lot of other competition, but we welcome competition. We came across one example where one of our distributors actually sells our stove and other stove products. And even though ours is more expensive, people said that they preferred our product and they were actually willing to pay more for our stove versus other models that were cheaper because they thought it was beautiful, because they liked it, because it was something that they wanted to use. So even though people constantly talk about cost as an issue, when presented with our stove among cheaper stoves, people preferred our stove, and as a result, one of our distributors decided to only go with our product as a result of that. So.
That's wonderful news. Since it is about 6 o'clock, let's just take a moment to thank our 4 panelists, Jason, Jessica, Arjun, and Steve. Thank you so much for... And I can tell from the hands in the audience that there's still questions, and we can certainly stay to answer those for a few minutes here. But for those of you who aren't able to stay, thanks so much for your participation and contributions today. Do you have anything you wanted to add? Okay, we're going to have one announcement, and then we can get back to some questions.
One announcement for all of the speakers. The speaker dinner tonight is going to be at 7:30 in the Norland Library. For those of you who do not know how to get there, we'll be meeting here at 7:10 and walking over together. FYI, if you don't know where the Norland Library is. Oh, Felicia, you have something to say?
Actually,
yeah.
There'll be pre-dinner conversation and drinks for the speakers at 6:30. And so the
Great.
doors will open very early for those who are willing to walk that way.
At Norland or here?
At Norland.
Okay, great.
And so the earlier, actually, the better for everybody, because it does get quite late for the conference tomorrow.
Okay, fabulous. So, Norland Library, 6:30. I guess that I'll be walking.
Where in Norland?
British
Studies upstairs.
fourth floor.
Yes.
And what's the talks?
No, that's a speaker's going to
Oh, that's for speakers.
Yes.
Okay.
So let me
So I'll be walking there right after this.
Okay, so let me clarify this. To all the speakers who have come from different parts of the world and come here, we have a special way of saying thank you, and that's to host a dinner in your honor. And Felicia is hosting it, and she's just announced that she would like speakers only and chairs to go to the Norland Library. The dinner is being hosted in the British Room, which is on the 4th floor. So I would strongly advise those who are going there not to sort of do your own thing and get to the Norland Library, but to walk across with us in about 10 minutes or 5 minutes. We can all walk across to the Norland Library and we should meet there. Would that be a plan? Okay. Yeah, so give us 5. You can do this for another 5 minutes, Jude, if you like.
Okay. Can you say just as you want?
Sure.
Okay.
People can ask. I think people have questions.
So
go
I
ahead.
remember hearing about the problem of these stoves, that people depended upon the stoves to also heat their space. So the stoves are so efficient that they don't heat the space anymore. So that was years back. So what has gone on about that problem?
Well, that's a very regional problem, and there are definitely particularly high altitude regions where cooking and heating are both really important. But in my view, you don't want to have something that couples 2 different needs and makes a mediocre solution for both. You want to have a really good stove for cooking and a really good stove for heating, or another system for heating. And when people have tried to combine them too much, and the same for lighting units, trying to make a stove be a really good source of light versus a solar product doesn't make any sense to me when you have a really clean, cheap solution for lighting.
So do they adopt it before you have space heating available for
So
them?
typically a cook stove is considered a much higher need than a heating unit, because, you know, I'm simplifying it, but you can huddle or wear blankets, and heating is...
Meanwhile, do you find that you have much more food you have to feed them to keep their calories up, to keep them, you know, shivering?
That may be the case, but even if their space was warm, they would need, obviously, to be able to prepare their food. And so the heating is, and this is up for debate, but the heating is considered a secondary need. It's one that I'm actually very interested in, but cook stoves is a primary need. It's in that top tier of people are going to need to cook their food or they're not going to survive, versus heating is slightly lower than that in the scale of importance.
I think that's it then. Thank you, everybody. It's been a great day.